Hello everyone, welcome to my channel. So now it's time to do the second question of today's Leetcode weekly challenge. So it's about closest nodes query in a binary search tree. So as it is a binary search tree and about the closest query, so from the question name only we get some hints. But now let us read this question and then about the constraint and then we'll go ahead. You are given the root of a binary search tree and an array queries of size n consisting of positive integer. Find a 2D array answer of size n where answer of I is min I and max I. Min I is the largest value in the tree that is equal or smaller than the query of I. If such a value does not exist, then add -1 instead. And max I is the smallest value in the tree that is greater than or equal to query of I. So it's like the max value would be the value which is greater than query of I, but it should be this smallest possible one. If such a value does not exist, then -1 we are required to return it in that place of max I. So at the end we are required to return the array answer. So here the constraints are 10 raised to power 5 means the number of nodes in the tree in the range of 2 to 10 raised to power 5, but it is a tree, so that's why as per the height and so on, if we traverse it, then it will become in the login scenario, and the node value is up to 10 raised to power 6. That doesn't matter much here. And query length n, and that could go up to 10 raised to power 5, and each query can go up to 10 raised to power 6. Okay, so here now let us first go ahead with the example. So here root of the tree which is being given to us, and here some queries are given to us. That is, now first one is 2. So for 2 we are required to check for the number which is basically greater than or equal to largest value in the 3 that is smaller than or equal to. First about the largest value that is smaller than this 2 is basically a number which is smaller than 2, and it should be the largest most value from all of the smaller values than this particular number. So here we figure out that, and even it could be equal to, so 2 itself would be the answer here, as here we can see. And then 2, then it asks for the smallest, this for the smallest, and now it asks for the large, yeah, maximum value. I mean basically a value which is smallest value in the tree that is greater than or equal to query of 5, greater than or equal to query of 5. So that's why this here we check for the smallest value which is either greater than or equal to the given query, that is again the 2 itself. Then comes the part for this 5. So for 5, if we check the minimum value, which is basically largest than all the minimum values, which are all the smaller values which are less, all the values which are basically less than 5. So if we check in this tree, then we are having this 4, which is less than 5, 2 less than 5, and 1 is also less than 5. But the largest out of them is 4, so 4 is required to be returned as answer. And then about the maximum value, that is a value which is smallest of all the greater values than the 5, that would be here. If we check that 6 is greater than 5 and all the values which are being there in this right subtree, but smallest out of them is 6, so that's why we are required to return 6 as our answer. So like this only we will be checking for other queries which would be there. So how we are required to go it, as we can see that it is a binary search tree, and we are required to check for something like which is greater or smaller. So in that sense, we can directly go ahead with in order traversal of this particular tree, so that it could return a sorted array, and in that sorted array we can directly go ahead with doing the binary search for getting our answer. So here This was about the overview that how we are required to do. So let us go ahead with the coding part for the same. So here first we are doing the in-order traversal, and because of this in-order traversal we are filling up this nums, and this nums would be a sorted array. And now after in-order traversal is being done, which we had called here, so now after this in-order traversal we got a sorted array nums, and that sorted array is basically we got from this. Now we will be checking this queries array which is being given to us. Now each query from that we will be going ahead. First we are here we are initializing with minimum maximum whatever value is there with -1, and if nums of 0 is less than equal to query, we are starting from that field, and then we will be checking the out of them which is the lowest most, and that we will be filling up in this mn, and then we will be checking for this mx is for the maximum one, and for that purpose we are checking with the last element, basically the largest element which is being there. If our query is less than, then only we are going out for checking this. Else, surely we would be required to return -1, the way it was here in this particular first. Now further steps, that if our mn is greater than 0 and mn is also greater than equal to nums dot size, then in that context we are required to remove that index and basically reduce that index, because we can't go it because of if it becomes greater than our nums dot size, then surely because of that fact only we won't be means it will be out of bounds. And then here we are checking that if our nums of mn, if it is greater than our query, because here we are required to return with the minimum element, so it can't be greater than our query, so that's why again we are reducing the index and checking for that element which is just before that. And then for the maximum element thing, we are checking that at that particular index if it is equal to query, and decreasing the same. And then if mn are not equals to -1, then surely whatever is there in the nums corresponding to that index, we are getting that in our answer. Else at the starting we were having this -1, so that would be pushed into our answer at that moment of time. So at the end we are required to return the answer after doing all the queries. So that this was for the coding part. Now comes the part for the time complexity. So for time complexity we can see that one is about this in-order traversal which is being there. So the time complexity for this in order is order of n, and then comes the part with query. So because of this queries, the time complexity here is for the order of, if we say that queries are k, so order of k. Then we are doing this binary search here. So for each binary search, we are doing the operation. I mean, the time complexity becomes the number of elements which are being there n, and the log n, basically just log n here, and same goes for this part. And then we are just comparing. So for this for loop, overall time complexity becomes k into log n. N is basically the number of elements which were being given here in this tree, and thus in order traversal time complexity. So the overall time complexity for the same becomes order of n plus k log n, and the space complexity becomes, because here we are using auxiliary space of this nums, and any other space we are not using. So that's why the space complexity becomes order of n. So this was all for the coding part and stuff of this question. One more thing I just want to convey. It's about that as you're doing already for all these coding contests, so you can also try out with Newton School coding contest, about which you can figure out for the details in the description below. And there is one link which will be having all the details for the same. So yeah, this was all for today's video. Thank you.